So guys, we are going to start thermodynamics, and these videos will help you in SSC JE. And now this one is the first video, and I am going to tell you about basic concepts of some thermodynamics properties. So first question comes, what is thermodynamics? So thermodynamics is the science of the relationship between heat, work, and temperature and energy. In broad terms, thermodynamics deals with the transfer of energy from one place to another and from one form to another. The key concept is that heat is a form of energy corresponding to a definite amount of mechanical work. So this was the general definition of thermodynamics. Here, what is thermodynamic system? This one is important because we can see some questions in SSC. They are asking about thermodynamic system. So what is thermodynamic system? The word system is very commonly used in thermodynamics. Let us know what it is. Certain quantity of matters or the space which is under thermodynamic study or analysis is called a system. Let us say, for example, we are studying the engine of the vehicle. In this case, engine is called as the system because everything happen inside this system. So this was the general formula for system. What is system? So simply you can see anything which is happen inside a boundary, it's called system, and the outside is surrounding, and which defines the surrounding and system is called boundary. So types of thermodynamic system, there are two or three types of thermodynamic system. First one is open system. As you can see open system in this figure, there is there is also mass transfer and energy transfer, because in open system we can see the definition: the system in which the transfer of mass as well as energy can take place across its boundary is called as open system. Means mass also transfer, energy also transfer in this type of system. At example, you can see boiling water in an open vessel, where transfer of heat as well as mass in the form of steam takes place between the vessel and surrounding. So here there is mass transfer and energy transfer at the form of heat. Now the second type of system is closed type system. So the system in which the transfer of energy takes place, only transfer of energy takes place, its boundary with the surrounding, with no heat, no transfer of mass takes place, it's called as closed system. Here in this closed system, only energy can transfer, mass cannot transfer. Example, you can see here example: the fluid like air or gas being compressed in the piston and cylinder arrangement is an example of closed system. In this case, the mass of the gas remains constant, but it can get heated or cooled. When the molecule of these gases are moving fastly, then cylinder where gas are inserted can be heat, can be cooled because of their molecular activities. So this one is the closed system. Now the third one is isolated system. As you can see, there is no mass transfer and heat transfer in this uh, photo, and we can see definition: the system in which neither the transfer of mass nor that of energy takes place across its boundary with the surrounding is called as isolated system. So this one is the basic definition, and you can see example: if the piston and cylinder arrangement in which the fluid like air or gas is being compressed or expanded is insulated it by isolated system, here there will be neither transfer of mass nor that of energy takes place. But you cannot get any isolated, properly isolated system, because there are some losses occurs in every system. So this one is about the thermodynamic systems. Now there are two types of properties which exist: extensive property and intensive properties. Intensive Extensive properties: some properties of matter depends on the size of the sample, while some do not. An extensive property is a property that depends on the amount of matter in a sample. In extensive property, some properties of matter depends on the size of sample, but in intensive properties, an intensive property is a property of matter that depends only on the type of matter in a sample and not on the amount. Other intensive properties include color, temperature, density, and solubility. So this one is the difference between intensive and extensive properties. Now we can see what are the intensive properties and extensive properties. Here we can calculate simply, and we can identify by dividing these properties into one and half parts. Like in intensive properties, pressure is intensive, temperature, density, concentration, melting point, boiling point, surface tension, and viscosity. And in extensive property, mass, volume. If divide this into parts, then we get different volumes, masses. So these are the extensive property depend on the mass of the system. Now there is one more process we call as quasi-static because of the speed of the process. The slow process in which all the states through which process passes are in equilibrium with one and another. All reversible processes are quasi-static processes, but all quasi-statics are not reversible. This one can be asked in EMCQ. So remember guys, all reversible processes are quasi-static process, but all quasi-statics are not reversible process. And you can define quasi-static as a slowest process only. Assume you need to eat a full cake. If you eat all at a time, there will be two states, one before eating and one after eating the cake. Here it is not a quasi-static process, as the state 1 and state 2 are not in equilibrium. So you can see and you can define quasi-static as the slowest process. Here you can see the diagram, pressure versus volume. Here they are making quasi equilibrium process from initial state to final state. This one is the simplest example of piston cylinder. When we are compressing our piston, so this type of curve will be formed, and this one is the quasi-static process. System remains infinite, similarly close to an equilibrium state at all times. Process occurs slow enough to keep the properties identical throughout the system. The interval of process change takes much longer time than system spontaneously adjust to a new state after the previous equilibrium state was destroyed. To connect states with line must be quasi equilibrium process. So this one is the example of quasi-static process. Now what are path and point function? Point function, they depend on the state only and not on how a system reaches state 2 from state 1. They are only depend on state. These are point function. You can see example: pressure, volume, temperature. These all properties are point functions. And in there are exact differential. Point functions are exact differentials, but path functions are not exact differential. They depends on the how a system uh, move from state 1 to state 1. These are inexact differentials. Area under the PV curve gives the amount of work done. So it's not a function of the end states of a process but depends on the path the process takes. Therefore, work is called a path function. Thermodynamic properties are point functions since for a given state there is a definite value for each property. Path functions are called inexact or imperfect differential. Point functions are called exact or perfect differential, as I already tell you. A path function is depend on not only the starting parameters and the ending parameters, but it's also depends on the path the function takes to reach from the starting point to the end point. On the other hand, a point function is depend on the state of the function only. The path taken by the system to complete its action does not affect a point function. So this all about the basics of thermodynamics. If you want this PPT, you can see the link in description. And after that, we are going to we also solve some numericals, because numericals are also asked in SSC JEE, and some MCQ question those are related to SSC JEE, and they are asking the basics of thermodynamics. So I hope you understand what are the process and what are these simple definitions in thermodynamics. So guys, I hope you understand it properly, and after this video I am going to tell you some questions based on these properties.